And now finally the parabola, the last of the conic sections. So there's 4 parabolas. There's a righty, a lefty, an uppy, and a downy. They all behave like this. And here is all the information you'll need right there to do. Alright, so first off, we're going to start off with find the vertex, focus, directrix of the following parabola. So, the focus and the directrix are halfway between the focus and the directrix is the vertex. So the vertex lives in between. So this distance and that distance is A. Alright, so before we go to this, we look at this, the first thing we've got to decide is which one of these is it. So we'll go over here and we'll look. This says y minus k squared. So y minus k squared, or x minus h squared, x minus h squared. So if the x's are squared, it will look like this one or this one. Now, because this is negative right here, it's going to look like that one. Now, we know that the vertex is going to be at the origin because it's not x minus anything or y minus anything. We know, if we look right here, that negative 4a, in front of that, we know that negative 4a equals negative 16, so a equals positive 4. So now we can draw it. So the vertex is here. We know that it's opening down, like so. We know that the a is 4. So the directrix is up here, is y equals 4. And the focus is here, which is 0 equals negative 4. So we've got the vertex, the focus, the directrix, and we've graphed it. All right. Find the equation of the parabola described below. Find 2 points that define the lattice rectum. We'll talk about that in a minute. We know that the focus is at negative 3, 0, and the vertex is at the origin. So the first thing we do is we graph it. And we know that the vertex is at the origin right here. We know the focus is at negative 3, 0, which is right there. We know that the focus is always inside the parabola. So that's what we've got. So now we've got to look over here and we realize that we have this one right here. So that's going to be y squared equals, and then we've got to fit, and we know that a is 3 because it's the distance from the vertex. And then we do negative 4 times 3 x plus 3. So I'm just using these formulas right here. Okay. All right. Now, the directrix is going to be here, and it's going to be x equals 3. So we've got, let's go through what we've got. We found the equation. We've done everything, but we've done some stuff we didn't need to do, but we do need to find the lattice rectum. Now, the lattice rectum is a funny name, but it's these points right here that are left up or down or left or right of the focus. And it's always 2a up, 2a down, or 2a left and 2a right. So since a is 3, 2 of those would be 6. So this would be negative 3, 6. And this would be negative 3, negative 6. So these are called the lattice recti. So we've taken care of that. All right. Use the figure to complete the sentence. If a equals 4, then the coordinates of the focus are. Well, that's 4. So I've got to go up 4, right? So up 4 would be 3, 6. Find the vertex, the focus, the directrix, and graph it. Verify using your graphing utility. So here we go. All right, so let's have a look and see which one it's going to look like. So it's going to look like this one because it's a y minus k squared and that value is positive. So first of all, we know that 4a equals 8, so a equals 2. We know that the vertex is going to be at 3, negative 1. We know it's going to open this way, like so. We know that the focus is going to be 2 in along here. So since this right here is 3, negative 1, and I go forward 2, that's the focus is going to be at 5, negative 1. The directrix is going to be x equals 1 because I'm going to go back 2. So we found the vertex. We haven't found the focus. We found the directrix. Oh, we have found the focus. We found the focus and the directrix, and we've graphed it. Now, to verify using your graphing utility, you actually can't because you have to solve it for y. So don't worry about verify using a calculator. You won't be able to unless you do some fancy algebra. So if you really wanted to, you'd have to solve this for y by taking the square root of both sides. It's a mess. All right. Okay, so we want to find the vertex, the focus, the directrix of the following parabola and graph the equation. So we're going to have to complete the square. So we're going to put all the y squared minus 8y over here, and we'll move all the other stuff that has to do with x to the side. Good. All right, on this one right here, we'll factor out that negative 8. And then we're going to complete the square on this. So that's going to be y squared minus 8y. And then we're going to have that and double and square it. So having negative 8 is negative 4, negative 16, and then we'll do that. So we've added nothing. Now this bit right here is y minus 4 squared. And actually we shouldn't have done this over here. So let's put this back. So now we're going to add 16 to both sides, which will give us negative 8x. Good. All right. So we know that it's going to open up. So now we have to graph it. We know that the vertex is going to be at 0, 4. We know it's going to open to the left because it's a y squared equals negative. We know that, so we've got the vertex. The focus is A. Now we don't know what A is yet, but we do know that 4A equals negative 8. So negative 4A equals negative 8. So A equals 2. So we'll go forward back 2. That's going to give us that was the 0, 4. So this is going to give me negative 2, 4. And then the directrix is going to be over here, is going to be x equals 2. So we've got the vertex, the focus, the directrix, and we've graphed it. Done. All right, so here's another thing to think about. We want to write an equation. Parabola. So first of all, we know this is a Downey, so we know it's going to be the x minus h squared equals negative 4ay minus k. So the vertex is 0, 7. So we know it's going to be x squared equals negative 4a y minus 7. Now the only thing we need to do is to figure out what the a value is, and we're going to do that by using this point right here. So we're going to plug in 3 for x. We're going to plug in 6 for y. A is going to be 9/4. So my equation is going to be x squared equals negative 4 times 9/4 times y minus 7, which is going to give me x squared equals negative 9 y minus 7. There you go. See how easy that is? Easy peasy lemon squeezy. All right, now we're going to move on to this last one. So a mirror is shaped like a paraboloid of revolution, so it's a paraboloid. will be used to concentrate the sun's rays. So this is, you probably did this. I remember doing this in grade school, where we had to make an oven using the sun, and so I made a little parabolic bowl like this, and I lined it with tin foil, made it be really smooth, made sure that it was a paraboloid, a paraboloid of revolution, and then it figured out where the focal point was, put a hot dog there and cooked it. So I actually did this in school. Many of you guys also did this. It's a standard thing to do in science class, but also in math class. All right, so a mirror is shaped like a paraboloid of revolution, and we know all this stuff. So the easiest thing to do is to center this paraboloid where the origin is. The vertex is at the origin. Okay. Now we know that it's this point right here is the point 7, and then it'll be 12. It'll be half of this distance, right? Because all the way across is 24, so half of 24 is 12. Good. All right, so now what we're going to do is just figure out what A is. So we know that it's an uppie, so we know it's going to be x squared equals 4ay. So now we just plug in 7, so that's 49 equals 4a times 12. So 49 equals 48a, which means that a equals 49 divided by 48. So we need to place the hot dog right here at 0, 49 over 48, whatever that is. And we're done. Pretty easy, right? Good. All right, so you've got everything.